Alright, this is section 4-3 on greatest common factor, the GCF. We're going to start with example number 1. Start with example 1. Example 1 says find the GCF, greatest common factor, of 12 and 20. So in this, now notice the last chapter we were doing the factorizations. So as we list factors, this is where it can get a little bit tricky, and sometimes the factor tree will help. Okay, but I think another good way of doing this also would be to list 12 like this. Notice I'm making a squiggly bracket and put 1 and 12 at the highest and lowest points. And then just go up from 1. Does 2 go into 12? Yes, it does. What does 2 go with? 6. So notice how I'm getting pairs. I'm actually shrinking the amount of numbers I'm going to try. So I'm between, there won't be any numbers between 6 and 12 that go into it. So what about 3? Does 3 go into 12? How many times? 4. And notice there's no numbers between 3 and 4. So those are my factors for 12. Let's try 20. So 1 and 20. Does 2 go into 20? Yes, it goes with 10. So notice I've shrunk the amount of numbers. Does 3 go into 20? Nope. Does 4 go into 20? Yes, 4 goes with 5. 4 times 5 is 20. So there's my factors for 20. So notice I didn't really try that many numbers. Those are the ones I've got. So what is the greatest number in both? You've got 1s are common, 2s are common, 4s are common. So it looks like the answer is 4 is the greatest common factor. That's how I do it. I think it's a good way. But there are other ways of doing it also when we have different numbers. And that's where the prime factorization trees will come in. So let's try one like that. This is example 1b. So this is GCF of 30 and 24. So, it might help to do these factor trees. 15 and 2, 5 and 3. So this one is 2 times 3 times 5. And let's do 24. 12 and 2, 4 and 3, 2 and 2. So this 24 is 2 times 2 times 2 times 3. Notice all those prime numbers that we got. So what do they have in common? They both have a 2 in common. They both have a 3 in common. So that's what they have in common. So all you have to do is take 2 times 3, which equals 6. So my greatest common factor is 6. Now I know you guys can probably do that in your head, looking at 30 and 24, and you probably know the answer is 6. But at least do the favor of listing all the factors. That is very helpful. And then we can try C. Example 1C says GCF of 54, 36, and 45. And I know you're probably thinking the answer is 9, and that would be correct. 9 is the biggest number that goes into all three of those. But we can show that also through our factor trees. So let's do that. Let's do 36. And let's do 45. 9 and 5, 3 and 3. So, I'm going to circle all these. These are the prime numbers. So this would be 2 times 3 times 3 times 3. This is 2 times 2 times 3 times 3. This is 3 times 3 times 5. So what do they all have in common? They all have a 3. They all have another 3. and this one has a 5, and neither of those have 5s. And so there's nothing else in common. So basically they all have 3 times 3, and as you can see, 3 times 3 is 9. So that's why GCF is 9, and my work now shows it also. Let's try example number 2. 2A. 2A says, well, there are 208 boys and 240 girls participating in a field day competition. Letter A says, what is the greatest number of teams that can be formed if all teams have the same number of girls and boys in it? Well, again, this would be GCF. So you can do this a couple ways. Factoring might be the best to do this one. 208, I know that 2 and 104 both go into that. This one would be 2 and 52. This would be 2 and 26, and then this would be 2 and 13. So this one is 2 times 2 times 2 times 2 times 13. Then we've got 240, simplified by a couple ways, 120 and 2, maybe 40 and 3, maybe 10 and 4, 2 and 2, 5 and 2. So 240, here's all your prime numbers. Looks like there's 2 times 2 times 2 times 2 times 3 times 5. So what do they have in common? They both have 4 2's in common. So what is 2 times 2 times 2 times 2? Should be 16. So the greatest number of teams that can be formed so that there's the same amount of boys and girls would be 16 teams. Alright, letter B in that same wants you to have how many girls and boys will be on each team. So since there's 16 teams, then all you're doing is taking 208 divided by 16 and 240 divided by 16. So let's do that. Again, showing work, decimal, 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 decimal. 2 does not, or 16 doesn't go into 2, it doesn't go into 20 once, and then 16 goes into 48 3 times exactly. So there'd be 13 boys on each team, and 16 doesn't go into 2, it doesn't go into 24 once, and 16 goes into 85 times exactly. So that means the answer would be 15 girls on each team. So there you go. That's using greatest common factor. And we have example 3 now. Here's example 3. Once GCF of 16xy squared and 30xy. So you might notice what are the letters that they both have in common? They both have an x and they both have a y. So in our answer, x, y will be part of it. But we can list all this out also. So let's do the GCF of 16. Let's do a factor tree. 4 times 4, 2 times 2, 2 times 2. And let's do 30. 30 becomes, here you go. 30 would be 2 times 3 times 5 times x times y. And then 16 would be 2 times 2 times 2 times 2 times x times y times y. So once you list out that factor tree, then you just find what's common. They both have a 2, they both have an x, they both have a y. So therefore my answer is 2xy is the greatest common factor of those monomials. Alright, and then we have one more factoring of the example 4. This is where this does get a little bit tricky. But example 4 has wants you to factor 2x plus 6. Now this does get tricky. Factoring this is a polynomial because you have two terms. So what happens is this is the opposite. Might be just something to think about or jot down as notes. This is the opposite of distribution. So we're going to go backwards into a distribution problem. What is the greatest common factor of 2x and 6? Well, they both have a 2 in common, so I bring that out. It's like I'm pulling out a 2, and then I leave a set of parentheses. So what would go right here to give me, if I distributed 2x? Well, x would go there. 2 times x is 2x. What would go here to give me 6? 2 times positive 3 if I distribute it back in. So my answer is 2 times the quantity x plus 3 would be my factor. All right, that is your notes. Good luck.